Hello friends, welcome to my YouTube channel Computer Science Classes by Nikhil Srivastava. And in this video lecture we will try to understand the concept of encapsulation. So what is encapsulation? So before trying to understand encapsulation, let us try to understand this concept with the word itself, what the word suggests. So if you think of encapsulation, then you can think in terms of a capsule. So let me do one thing. I will not save this. I will draw. Can you guess what I will draw? I will draw a capsule. So what does a capsule looks like? A capsule looks like this. I'm talking about those capsules that doctors give you generally. So inside a capsule, you have some medicine inside the capsule. Suppose this is a medicine that is inside the capsule. So this is a capsule. So what is important? This is the medicine that is inside the capsule. This is the medicine, and this is the outer cover. This is the outer cover of the capsule. So what is important? Of course, the medicine is very important, and that has to be protected. And the outer cover is just there to protect the medicine, to protect the medicine so that it does not get spoiled. It does not becomes harmful for the patient who takes it. So from this example we can understand the concept of encapsulation. In encapsulation also, when we talk about the concept of encapsulation in OOPS word, then in OOPS word we have to protect, like in this example we are protecting the medicine that is inside the capsule through the cover of the capsule. In encapsulation also we do the same thing. We try to protect our data members and data variables of the class. How we try to protect the instance members and instance functions of the class? Let us look with the help of this example. So I will do one thing. So before trying to, let us try to understand the literal definition of encapsulation. The literal definition of encapsulation says that encapsulation is an object-oriented programming concept that binds together data and functions, that manipulates the data and keeps both safe from outside interference and misuse. So what is exactly this outside interference and misuse? Let us try to understand this concept. So over here, I have a class, and what is the name of the class? The name of the class is student. So in C++, there is so you must be knowing. So encapsulation is implemented. Encapsulation over here, it is implemented through the use of accessibility modifiers. So what are accessibility modifiers? Accessibility modifiers like the private accessibility modifier, the public, and the protected accessibility modifiers. So we will try to see and understand the accessibility modifiers in great details when we go to inheritance. But over here, just let me state that private accessibility modifier states that all those member functions and member variables, those are private, can only be accessed within the class. And public means that they can be accessed from even outside the class. And there is one more important thing that is very specific to C++. I will write it down on a notepad. The default accessibility modifier in C++ is private. Okay, so what does this mean? The default accessibility modifier in C++ is private. So over here, if you go, I have declared 3 member variables in the student class, but I have not declared any accessibility modifier. That means the default accessibility modifier is private, which means that student ID, student name, and subject are all private. And I will show you. For example, if I construct an object of the student class, I have constructed an object of the student class, but now suppose if I try to access the name of student. Suppose if I try to access the name of student and I write something like this. cout s1 dot name, cout s1 dot name. If I try to, this is already is showing a compile time error. If I try to clean and build this application, what will be the output? You see, it is not building. You see, and there is also the student name is private. This is private, and this is what I told you exactly. If the default accessibility modifier is private, so if you have not given any accessibility modifier, explicitly stated any accessibility modifier in this class, that means student ID, name, subject are all private. But now let me do one thing. Let me make all of them public. And how will I make them public? I will write something like this, public. Now the student ID, name, subject are all public. And now suppose again I run this application, clean and build. You see the errors have gone, and now you can see build successful. That means it is compiling without any errors, without any compile time errors. That means when the name is public, it can be accessed even outside the class. See, this is my class boundary. This is my class boundary, and I can access the name even outside this class boundary in the main method. Now I can do something like this. What can I do? s1 dot name equal to say s1 dot name equal to say, suppose a very famous actor in Bollywood film industry, say suppose Amitabh. Okay, and then I say cout s1 dot name. Then what will be the output? Clean and build. I think this is very clear. This is very simple. It will just give the output as Amitabh. If I run this application, Amitabh, okay, you will see Amitabh over here. So this is no issues right now. There are no problems with this particular piece of code, but there can be some specific problems with this. If I write my class like this, what can be the problem? There can be some specific problems. For example, I make one more change. I declare the age of the student also. Okay, now what I do, I say that the name is, say suppose la 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 la. Okay, this is the name, and I say s1 dot age equal to, say suppose minus 21. I say like this. Okay, suppose I don't say I say, so I will just use a very slang language. Suppose if a person is not very intelligent, you say them he is a fool, but there is no person whose name is fool. But I say that the name of this object, that the name of this person who is represented by the object s1, his name is fool, and his age is minus 21. Age is always positive, it can never be negative, but I have given the age to be minus 21. Now what I will write is, I will say the name of the person is like this, a new line marker, and then I'll copy this code and I'll write something like this, age, and the age of the person. Will this particular piece of code compile? Yes, it will compile, it will run, but just see what will be the output. I will just clean and build this particular piece of code, and then I will run this application. It is working, but over here you see the name of the person is fool, the age of person is minus 21. But how come this is syntactically correct, but it is absurd in real world? There is no person whose name is fool, and there is no person whose age is negative. So you see over here that my ID, name, subject, which are the members of class student, are not secure, and that is what is the principle of encapsulation stating us. It is stating that you make all these member functions and variables which are present inside your class, you make them secure from outside use, and from outside the class I am setting some values of name and age which are not at all viable. So I need to secure, I need to protect my class member variables and functions. I need to protect them. So how can I protect them? One way, of course, to protect them is that you make them all private. I make them private. But if I make them private over here, then again there is one problem. What is the problem? Because I make them private, I cannot access them from outside the class. So if I cannot access them from outside the class, no one from outside can set some absurd values to these members variables, So but how then can we set these member variables and functions? We can do it through the use of public setters and getters. Always remember what I have written in this slide. Is that encapsulation is implemented through the use of accessibility modifier. Principle of encapsulation suggests to keep member variables of a class private and member functions that manipulate them public. So what does this exactly means? These are my member variables: age, subject name, student ID. These are my member variables. These all have to be declared private, which I have written over here. If you go to the third point, principle of encapsulation suggests to keep member variables of a class private. And then what should be kept public? So all the member functions that manipulate these member variables, they have to be declared as public. So over here I say void set name. There is one suppose I say like this, and name equal to n. Okay. Suppose first of all, let me do one thing. Let me design one method, void show student. This is one method, and inside this method I am going to display the whole data of student. How will I display the data of student? I will write something like this: cout the SID of student is SID, and then new line marker. I'll copy this code and then I'll paste it 4 times. Okay. The name of student, the subject of student, and then the age of student. Over here also I will write the name of student, the subject of student, and then the age of student. So I have designed the show data method. This method is used to display the details of every student, show student method. Okay. Now in this I'm using the principle of encapsulation. So the principle of encapsulation states that I don't make these member variables public, I make them private, and the functions that manipulate these member variables, I make them public. So here what I do something like this: string get name. So generally it is done through the use of getters and setters. Return name. Okay. Like this. I'll just copy this, and these subject s, subject equal to s, first of all, just let us stop at this at just over here. Now just observe this code. Now I have made the name private. So I cannot access the name from outside the class. If I write something like this, s1.name, which I have already shown you, if I write something like this, then this will give a compile time error. It will not work out. So if I have to access a name, then I will use this get name function. This is the getter function for name. If I have to access a name, and if I have to set the name, then I will use this setter function. How will I go for it? Like, for example, suppose I say that s1.set name. Suppose I set the name to be Amitabh. and then I say cout s1 dot get name. I say something like this, okay, over here. Now what will be the output? I think the output will be very clear. How the output will be there? I just clean and build this application, and I run this application. Just see the output. Output is of course very obvious. It is Amitabh. If you are not able to understand this, then I'll just explain this. S1 dot set name. I have passed the parameter as Amitabh. This parameter is collected in this variable n. This is an instance function, and inside this instance function, name is set to the value of n. N is Amitabh, and a name, this name belongs to the current object. What is the current object? The current object is S1. That means the current object's name, that means S1 name is set to Amitabh. And then once I say get name, the get name is returning the names. Whose name? S1's name. And what is S1 name? It is already been set to Amitabh. So this returns Amitabh, and this is I am printing on my console. The console outputs as Amitabh. Okay, so this is what has been done till now. But over here, so here also you can see I can do something like this. I can do something like this. What I have done before, I can say s1 dot set name full, s1 dot get name, and then will this application run? Of course it will run. Clean and build, and then I run this application. You see the name has been declared again as full. This is what we were trying to prevent. Previously we were setting the member variables private so that no one from outside the class can set some absurd values to these variables. But again we have seen that inside these setter inside these method I can again set some absurd value. So how can we protect the class? This is a very important question. Still we can protect the class with the help of these member functions. How can we go for it? Just see with the help of this example. Here I have said that the name is so what you can do inside these member functions, you can write some application logic. Suppose if I say like this, if n is equal to, suppose I say full, if n is equal to full, then I can say cout not a proper name, else I can say name is equal to n. So this is the advantage of using member functions. You can write some application logic that can protect your member variables. Inside member functions you can write some application logic to protect your member variables. That is why you generally make your member functions as public. So here you see, now again I run this particular piece of code. So here I clean and build this application. Build successful, and I run this application. What is name? Okay. So it is just outputting not a proper name. When I'm setting the value of name to be full, it is saying not a proper name. But if I set some proper value, say I say suppose Neha, this is a proper name. I set, so Neha is a proper name, so I am not doing any kind of check against Neha in my setter function. So over here, if I go and build this application and I run this application, so it is displaying Neha. But again, if I have some absurd values, then you cannot do it. Then similarly it is the case with it's a case with age. Age can never be negative. Suppose my school policy, suppose all these students belong to a school, and the school policy states that the school never takes any student who is below 3 years of age. So I can do something like this. What I can do, I can create a setter function for age, set age, and suppose the age is passed in a parameter a. Now I can check it. How I can check it? I can say if a is less than or equal to 3, if a is less than or equal to 3, cout not a proper age. Okay, else else I can do, I can write age equal to a, age equal to a. Okay, this is my setter function for age. I just yeah, here you go. Okay, just making this code more readable. Yeah, all right. So you are checking whenever you are setting the age inside this member function, you are checking if age is less than 3. If age is less than 3, you are not setting the age. If when age is only greater than 3, then only you are setting this age variable over here. Similarly, I can also design a getter for the age. How? So age is of type integer, that is why the return type of this method will be int, and then I will say get age, and inside this get age function I will say return age, and then I will design the setter and getter for my SID also. So how will I design the setter and getter for SID? I will just copy this. SID is of type int. So when you will design the setter, you will say void set SID, and SID of type int, that is why it will take a parameter of type int s. And how will I set SID equal to, say suppose s, and integer get SID. Inside this method I will just write return SID. Okay, like this. So here you can see this is a this is proper. So the basic advantage of using member functions is that you can write some application logic inside that can be checks, so that your member variables are protected. So they are the, I will just write comments, setters and getters for subject, for name, sorry, these are the setters and getters for name. Just copy it. These are the setters and getters for subject. These are the setters and getters for age, and these are the setters and getters for SID. Okay, so what I have done over here, if you look at this class as a whole, what I have done, all these member variables I have declared them as private, and suppose name is over here, name is private, but if I want to access name from outside the class, then I will use the setters and getters of name. If I want to set the value of name, then I will use the set name function. Suppose s1.set name Amit, Vishal, Neha, whatever name you want to set. And if you want to get the name of what is the name of the current object, then you will use the get name function, s1.getName. So this is the concept of encapsulation. Okay, so over here I have stated also the principle of encapsulation suggests to keep the member variables of a class private, and the member functions, just see the third point, and the member functions that manipulate them public. Okay, so over here you can see these set name, get name functions are manipulating name, so I have made them public. Similarly, it is the case with age, subject, name, age, and SID. So you can write some application logic inside your member functions to protect the member variables. Okay, so this is the concept of encapsulation, and encapsulation is implemented by the use of accessibility modifiers, the private and the public accessibility modifier. Thank you so much for watching my videos. Please keep on watching my videos more, and please suggest them to your friends, your colleagues, and do subscribe to my channel. Thank you so much for watching them.